This is 7-1 notes, multiplication properties of exponents. In this lesson, you're going to learn how to, what a monomial is, and you're going to learn how to multiply monomials, and then you're going to also learn different properties of multiplying terms or numbers with exponents. So to begin, we got some vocab. A monomial is a number, a variable, or the product of a number and variables. Mono means one, so it's one term of a bunch of numbers and variables being multiplied together. Mono means multiply, think of that. Product is multiplication. A constant is where the monomial is a real number. There's no variables with it. It's just going to be that number. It will not vary. It stays constant. So to give you some ideas of some monomials, and then what is not a monomial. A monomial can be a number. 5 is a monomial. This is actually considered a constant because constants don't have variables with them. They will consistently be 5. It can be a variable. X is a monomial. And then it can be products of numbers and variables. So if I took the number 5 and the variable x and multiplied them together, 5x, I can take x squared y, okay, because the x squared is really x times y. It's all multiplication. And another way to write this would be maybe x, if I show it as division, it can be divided by a number because x divided by 3 is really multiplication of 1/3. So that's a tricky one. Even though division is not a monomial, if you're dividing by a number, it works. So what's not a monomial? If you're adding these things. Okay, that's the addition of two monomials. X is a monomial, 5 is a monomial, but that's the sum of monomials. The difference of two monomials is not a monomial. And then if you had a product, but then you were dividing by another letter, a variable in the denominator is division. The top numerator is a monomial. The denominator is a monomial, but that would be division of monomials. So think of mono like monotone means one. And so mono means one term, all put together, no pluses or minuses between them. So let's just quickly go through and make sure we have an understanding of whether something is a monomial or not. So part A, letter A, 10, yes, it's a monomial. And it actually is a constant. This is a constant again. B is not a monomial. And the reason it's not a monomial is it's a sum of two monomials. F is a monomial, 24 is a monomial, and they're being added together. C, h squared, yes, it's a monomial. It's the multiplication of two h's. H times h is h squared. D is okay. Yes, it's a monomial because the division of 2 is really multiplying by 1/2. So I just want you to understand that when you're dividing by a number, it's the same thing as multiplying by its reciprocal. So that's a monomial. That's a number 1/2 times x times y times z times z. So it's all a monomial, multiplication of numbers and variables. E is not a monomial because of the division of n. This is a division of two monomials. So MP is a monomial, N is a monomial, but when you're dividing them, that's not considered a monomial. That's considered the division of two monomials. So that's part of your homework or your classwork tomorrow will just be identifying monomials. The next part, we have some terminology of a power. The best way to describe a power is its repeat multiplication of a number. A power represents repeat multiplication of a number. And in a power, you have the exponent. That's the little number. It's a superscript. It goes up above, and it's tiny. That's your exponent. And then you have the base. And so what that tells us, a power tells us what we're going to multiply. The exponent tells you to repeat the multiplication. So if I have 5 to the 4th power, it's telling me that little 4 is telling me to take 5 4 different times and multiply it by itself 4 times. Repeat multiplication, and you end up with 625. If I have x to the 3rd, that is telling me to repeat the multiplication of x 3 times. Okay, so we're going to get into powers with variables, and there's some rules that go with it. I'm going to show you how to expand when we multiply powers with variables and monomials, and then I'm also going to show you through the expansion the rule, a little shortcut that you can use. So there's 3 different multiplication property rules. Property is just a fancy name for a rule. So there's the product property, power of a power, and power of a product. Okay, so I'm going to show you expanded form. From the expanded form, we'll write a rule, and then I'll show you just another example of applying that rule. So on your homework, or when we do this work, I'm going to expect you to do both, and that's how you're going to decide if your answer is correct or not. You're going to have to learn how to expand, and then you're also going to have to learn how to use the rule. So the product property is basically the property that allows us to multiply 2 monomials. If I have x to the 5th and I'm multiplying it by x squared, I can expand that and define what does x to the 5th mean. X to the 5th means 5 x's being multiplied together here. There's my 5 x's. And then x squared is just multiplying by 2 more. Everything's multiplied together. And so you have 5 x's multiplied by 2 more x's. When you count them all up, this is the multiplication of 7 x's. And so what you get, the repeat multiplication of 7 x's, can be written as x to the 7th. So that is expanded form. Understand and break down the meaning of x to the 5th, x squared, and you get 7 x's listed there. Now if you look, that's a lot of x's to write down. And so if you look up above, how could I get 7 using the exponents? I could simply add them together. And so that leads us into our rule. If you have some number a raised to the mth power, I'm just using variables to describe every number, and then you have that same number, a or x or y, raised to a different power or some other number, you simply can say it's going to be that same base, a, to the m plus nth power. And that's the rule. Okay, so let me show you in terms of variables. If I have p to the 5th and I times it by p to the 4th, in my head I can expand it out and say I'm going to have 5 p's and then 4 p's multiplied together, or I can just say p to the 5 plus 4, which is p to the 9th. Sorry about that. So I really don't need to see that you write 5 plus 4 up in the corner. If you want to use the rule, you look at this, it's multiplication, which means you're going to add the exponents. When you multiply exponents of variables, you really just add the exponents. Power of a power. A power is something raised to an exponent. So if you take an exponent and then raise it to another exponent, this is what we're talking about. So if I have x squared, which is a power, and then I cube it, take it to the 3rd power, let's understand what that means. When I cube x squared, it really means multiply x squared by itself 3 times. Repeat multiplication 3 times. And then now I could even expand that, and each of these x squareds I can break down into an x times x. And you end up getting 6 x's multiplied together, or we can write that as x to the 6th. Now that's a lot of work again, and so it leads us into our rule. How do I get 6 when I have a 2 and a 3? You can multiply. So when you have a base a raised to some power m raised to another power n, you multiply and call it a to the m times n. So as an example, If I have t to the fourth to the third power, I don't have to expand it using the rule. I would call that t to the 12th. Multiply. Power to a power, you multiply. When you multiply, you add the exponents. All these lovely rules to memorize. Power of a product is basically taking those two rules and putting them together. So I'm going to take a product, which means I'm multiplying inside. So maybe an x squared and a y cubed. And then I'm taking that to a power. Maybe I'm going to square that. So if I'm going to square that, that means I have an x squared times an x squared, because there's two of them, and then a y cubed times a y cubed. I'm squaring each of those terms inside. And we can expand it even further. That gives me 4 x's and 6 y's. And so what we end up with is x to the 4th, y to the 6th. And when you look at the original problem, how can I get x to the 4th, y to the 6th? You apply the power to each individual item inside the parentheses. It's a product. And so the rule states, if you have some base raised to a power, a to the nth, multiplied by a different base raised to a different power, let's say b to the nth, and you take both of those to a different power. So you have a product of a and b raised to another power. You take the p-value, that power, to each of the individual terms of the product. A to the mp, b to the np. So to give you an example, if I show you 2x cubed cubed, what that means is I have a product. 2 times x cubed is a product. They're being multiplied together here. It's really a 2 times an x times an x times an x. So as long as I apply that exponent to the 2, now the 2 has a 1 up here. It's 2 to the first. And so if I take 2 to the third times x to the 9th, I applied the cube of 2 and the cube of x cubed. 2 cubed is really 2 times 2 times 2, so we should write 8x to the 9th. Anytime you have a power of a number, you should always simplify it to a nice number. All right, so those are the rules that we're going to use. So I'm going to go ahead and we got to talk about simplifying. Your homework's going to be about simplifying. In order to be simplified, it's sort of a checklist. If you ask you to simplify a monomial expression, each variable base appears only once. So if you have more than one x value, you need to combine them. If you have an x squared and an x to the 5th, you need to put them together and have just one x. No powers of powers. So if there's a power to a power, you need to apply that power through. And all fractions must be reduced and be in simplest form. I apologize for the bell. All right, so we're going to try these examples and see how it goes. I'm going to show you each type. I'm going to go kind of fast, but you can pause and try to understand how I'm applying the rule and then look at the expansion. So for number 1, I can use the rule, and there's a 1 out in front of that x squared. I have 5x to the 4th, and I have 1x squared. So if I multiply, this is all saying multiplication, multiply numbers like we've always multiplied numbers. That does not change. I have a 5 times a 1 gives me 5. But then when I try to multiply an x to the 4th and an x squared, I really didn't know this until today that I can use a rule. I'm multiplying, and so I have x to the 4th and x squared, add the exponents, and you get 5x to the 6th. Using expansion, I can rewrite this as 5 times x, 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 times x, x. And you'll realize you have 5 with 6 x's, so you have 5x to the 6th. Okay? Number 2, using the rule, I'm going to multiply. Now maybe if you understand that all this is multiplication, okay, anything, all the numbers being written next to each other than the two quantities, it may help you if you want to just put the numbers with the numbers, put the a values with the other a values, the b values with the other b values. That might be a nice first step to do. Now, when I go to multiply 4 and negative 7, it becomes negative 28. We multiply numbers.
Michelle Kennedy, please come to the main office. Michelle Kennedy to the main office.
So we have lots of interruptions. Negative 28 is your multiplication. A to the first and a squared makes a cubed. B to the fifth, b cubed makes b to the eighth. Using the expansion rule, you could write 4 times negative 7. Those are your numbers. A times b, 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 b. A, b, b, b. And I would even group them together. So even as I expand, I could have put these two A's with this A, put these 5 B's with these 3 B's. And then you can see that we still have negative 28, A to the third, B to the eighth. All right. Let's skip number 3 and go right on to number 4, just for time purposes. So again, I'm going to group my 6 and my 5 together. I'm going to put my C with my C to the third, D to the fourth, and D squared. I can do that whether I'm going to use the rule or if I'm going to expand. When I do that, 6 times 5 is 30. C to the fourth, remember C to the 1 power here. So when you add the exponents, you get C to the fourth. And then I have a 4 plus a 2 makes D to the sixth. In expanded format, I would write 6 times 5, put the numbers together. I have a C and then 3 more. I have 4 D's from the first quantity and 2 more. And I can clearly see I have 4 C's and 6 D's. 30, C to the fourth, D to the sixth. Now in the beginning, I'm going to require that you do both. Use the rule, then expand it, and if they don't match, we want to go back and look and see where we went wrong. All right, a couple more and then we'll call it good. Number 5. Number 5, I'm looking at that, and you know what? I don't want to use the rule first. I want to expand first because I don't understand it. So lots of things going on here. I have a power to a power to a power. So I am going to multiply those powers, those exponents, but let's expand it first. A to the fourth cubed, if I just take this inside part, A to the fourth cubed, I could say that that means take A to the fourth 3 times. So I have A to the fourth, A to the fourth, A to the fourth. That's 3 times. But then they want me to square that. So now we're going to take these 3 A to the fourths and write them twice. So that's A to the fourth times A to the fourth times A to the fourth. There's once. And then 3 more. Lots of 4's going on there. Now, truly to expand that, I should write down all these A's, right? There's 4, 8, 12. I don't know why the bells are ringing. So we have 24 different A's that I just wrote down there. And so it become A to the 24th power. Okay? You might even see in the expansion that this is as far as you need to expand it. As you get going with these things, you might say, okay, that's far enough. Now I know I just add these all up. Well, how many times are you adding 4? 6 times. And 6 times 4 is 24. From the very beginning, we could have taken this problem and A to the fourth to the third. When you multiply that, you get 12. Squared is A to the 24th. Multiply 4 times 3 times 2. Okay? Number 6, it says find the volume of a cube with the side S. Well, if you know that volume of a cube is the side cubed, and so the volume would equal 5x, y, z cubed. Okay? Expanding that, that means 5 times 5 times 5. I just applied the cube to the 5. X times x times x. Y times y times y. Z, z, z. 5 times 5 times 5 is 125. It is not 15. A lot of people look at that. You're erasing this 1 here. There's a 1, 5 to the first. X cubed, y cubed, z cubed. You cubed everything inside the parentheses. Now, if you use the rule just states I have 5x, y, z. Okay, they all have a power of 1 in here. So when you take the power of a product, you apply that power to every single term. And so I multiply every single exponent by 3. So 5 to the first cubed becomes 5 cubed. X to the first cubed becomes x cubed. Y to the first cube becomes y cubed. And z to the first cube becomes z cubed. So the only thing that we'd have to clean up is the 5 cubed. The hardest part of these a lot of times is the number. You're going to mess up that 5 cubed more than you're going to mess up the other variables. I think that's enough examples for the day. So your lesson summary, what do you think is easier, writing out or using the shortcuts if you can explain? And simplify that power of a product, 3x squared cubed.